if I were to draw a hexagon up here, okay? Yesterday we talked about a hexagon being a six-sided figure. And not only is this a hexagon, but this is a regular hexagon, okay? What does it mean to be regular? All the angles and all the sides are congruent. So not only are the sides congruent, but the angles are also congruent. Okay, so the fact that this is a regular hexagon, what would be the first thing that I would have to do to find the measure of an inside angle? What did we talk about yesterday? Okay, yep. N minus 2 times 180. So because this is a hexagon, we know we got 6 sides, so this would be 6 minus 2 times 180. So that would really be 4 times 180, which is 720. So that means there's a total of 720 degrees inside of this figure. And I'm kind of going through this one because we had one like this or similar to this yesterday on our assignment. I had a couple people ask me about it, so I kind of want to make sure we understand what's going on here. This is the total of all 6 of these angles, right? That's how many total degrees I have inside of that figure. I want to find one angle. But in this case, what do we know about all 6 angles? They're all equal, right? So because they're all equal, I can divide it by 6, and I can get each individual angle. So each one of the angles on the inside of that hexagon would be 120 degrees. 120 added together 6 times would get us up to 720. Okay? And that was really our focus yesterday. And then today we're going to take it a little bit further, okay? Because this is a continuation of 7-1. Today we're on day 2. Those are only the interior angles. Today, we're going to look at an exterior angle. An exterior angle is where I'm going to extend the side, and you could do it to any side. I just did this top side right here. And we're trying to find the angle on the outside of the figure if I were to extend that side. Okay? And think back to last semester. What do we know about these two angles together? They equal 180, right? They make a line. So they're just going to make a straight line. So if we know that this is 120 in here, then we know that the angle on the outside has to be 60. Okay? And all the way around, these would all be 60. Okay? Now, I'm going to show you this, and only because this kind of gives you a visual of kind of what's going on here. But if I were to start right here, and I go all the way around the outside of this figure, and my picture's not the best picture, but what I have formed is if I started here and go around the outside and touch every vertex of that polygon, what have I essentially formed here? What's this going around the outside of the figure? It's a circle, right? How many degrees do we have in a circle? How much? 360, okay? So how many degrees are there going to be on the outside of a figure? 360, okay? What if I only have 3 sides? 360. What if I have 12 sides? 360, okay? Because if I were to draw a triangle up here, and I go from here, and I go around, I've formed 360 degrees, okay? All of the angles on the outside are going to form essentially a circle because you're going from one point and we're going all the way around and starting at the other point, okay? So no matter how big the figure is, 3 sides, 10 sides, 12 sides, whatever, the outside angles, the exterior angles will always add up to be 360, okay? So one of the biggest things that I will tell you here is for exterior, the total of this is 360, but each angle on the outside was 60 degrees for that six-sided figure, okay? So you're gonna have to really pay attention to what question is being asked. Are they asking me for one angle, one exterior angle? Or are they asking me for the sum of all of the exterior angles of that figure, okay? And there's lots of different questions that they could ask us. The same thing up here. 720 was my total. Each angle inside was 120, okay? So one angle inside, or we're talking about the whole thing inside. So what I basically just talked about here is the same thing. They did it with a 5-sided figure instead of a 6. I just kind of started from the beginning. But here we have 1, 2, 3, 4, 5 sides, and we have 5 exterior angles. But no matter how many sides I have, the total will always be 360 because it goes all the way around the outside of that figure and basically forms a circle. And we know a circle is always 360, so when we go around the outside of the figure, it's also going to be 360. Okay, so that's really the basis for everything that we're going to do today. As long as we have a polygon, then the outside will always add up to be 360. And that's what this theorem is telling us. This theorem is everything we just talked about. It doesn't matter if it's 5 sides, 3 sides, 10 sides, 12 sides. It's always going to add up to be 360. So the key here is the 360. Okay. It does not change. Yesterday our total changed. As we added more sides, we added more angle, right? We added more angle measures to it. But when I only have all of the angles on the outside, it's only going to be one total measure for the exterior, okay? So it's quite a bit different than yesterday. Anytime you see the word exterior, we already know the sum of the exterior is going to be 360. It's not going to keep going up, okay? And a lot of people think that would be the case. The inside's going to go up, but the outside will not. And the reason why that changes is because as this inside angle goes up, then the angle across from it is going to be smaller, right? But if this gets smaller, then this one's going to get bigger. So they kind of have an inverse relationship. One's going to go up, the other one's going to go down, so they can still have that same relationship of what's going on. So as we look at this problem at the top of the next page, we have a quadrilateral because we got 1, 2, 3, 4 sides, and they went ahead and extended each side. Okay, so we have 4 exterior angles, and that's the question you need to ask yourself is where are my angles at? Are they on the inside or are they on the outside? On Big Ideas today, what I'll tell you is we pulled in some questions from yesterday and tied them into today's assignment so that you have some practice of both interior versus exterior, so they're not going to all be exterior questions today. So really be careful of the problems and what they're asking. Because we're trying to tie all of 7-1 together and not just focus on the exterior today. But in this case, we have 4 angles. But how many I have doesn't really matter, right? If I have 4 angles, 5 angles, 6 angles, whatever, they're all on the outside. And we know that the exterior always equals 360. So these 4 angles on the outside all have to add up to be 360. And it really doesn't matter what you start with, but I'm just going to write all these down. 2x plus x plus 67 plus 89 equals 360. You add up the 4 angles, set them equal to 360, and then it's just a good old equation, right? Type of equation that we solved over and over again throughout this year, throughout Algebra 1. We're going to combine like terms. So we're going to combine the x's together. 2x and 1x makes 3x. 67 and 89 add together make what? 156. Okay, and then it's just a 2-step equation. So from there, we're going to subtract 156 from both sides. 360 minus 156. Okay. And then 204 divided by 3. 68. Okay, we talked about this a little bit last semester, but be careful of what you're answering here. X is not an angle. X is just the value of X. Okay? Now, if I said over here, this would be 68 degrees because this angle is X. So when I solve for X, you don't have to put a degree symbol on here. That's just the value of X. If I put it in here, then this angle here would be 68. This angle here would be 68 times 2. They're not asking me to solve for the other two angles, but that would be something I could easily do in this case, and that could be a question that's asked. So really pay attention to what the question is that they're asking. I know I say that a lot, but it's a really, really important part of what we do. Okay, are they asking us for X? Are they asking us for the angle or a side or whatever it is that we're trying to do? All right. Hexagon. Hexagon is how many sides? Six. Okay. Hexagon is 6 sides. Okay. And the key words that we're looking for here is we have a 6-sided figure because it's a hexagon, and we're talking about the exterior angles of that hexagon. So what do we know about the exterior angles of any figure? They add up to be 360, okay? So we're going to add all of these together. And right here, there's 5 angles. So we know 5 of them. We're looking for the 6th angle, right? What would that 6th exterior angle have to be to make that total of 360? Now, you don't necessarily have to do it like I did on the last one where you write out the whole thing. If you wanted to, you could easily just add these 5 angles together. And that's probably what I would do first. Rather than writing all those down again, I would just add these 5 angles up. So let's add 34, 49, 58, 67, and 75. What do those add up to be? 283, okay. So that's our equation, okay? And I think that's a lot quicker than having to write all those out again because we're just adding them together. And then this is a really, really easy equation to solve, right? It's just a one-step equation. All I got to do is subtract 283 from both sides, and we're left with 77. So 77 would be the 6th angle, outside angle of that picture. All right, on these last two, I'm going to show you 2 different ways to do this, okay? And I kind of think one way is easier than the other, but then you can kind of, once you see both ways, you can kind of decide for yourself which way you'd rather do it, okay? I'm going to do the way that we would have done it yesterday, and then I'll do it another way, and I'll kind of show you the difference between the two. So on this first example, we're looking for the interior angle, and this is one we did not talk about yesterday. It's not one that we see very often, but it does have a name for it. Anybody want to take a guess what a dodecagon is? How many? 12. Yep. N is 12 here. So a dodecagon is 12 sides. We won't see that very often, but it might be one that we see off and on. I didn't include it in that list we did yesterday, though. So we have 12 sides. I want to find out what the measure of one angle in a dodecagon is going to be. So we're going to use that formula from yesterday. 12 minus 2 times 180 is 10 times 180, which is 1,800. And then we divide it by how many sides we have, which is 12. We'd have 12 sides, and we also have 12 interior angles. So just however many sides that we have. So then 1,800 divided by 12 gives me what? 150. Okay, so 150 degrees is the measure of each interior angle. When I do the exterior angle, okay, we know that the interior is 150. So what would this little one right next to the 150 be? Because what do those two have to form? How many degrees do those angles have to make? 180. They make a straight line, right? The interior angle and the exterior angle will always be right next to one another. So these two angles together must add up to be 180 every time. And so an easy way to find the exterior angle would just be 180 minus 150. And that would be my exterior angle. Okay, here would be a quicker and easier way of maybe going about this. And it's basically the same idea. But if I have 12 interior angles, how many exterior angles do I have? You have 12, right? The same amount. I have 12 interior, I have 12 exterior. But what's the total on the outside? Always 360. So what I could have done is I could have just done 360 divided by 12. Because the 360 is never going to change on the outside, right? It always stays the same. And so 360 divided by 12 also gives me 30. And then you could have used this one to get here. Okay? And that's what we're going to do on this last one. Is let's say instead of the trampoline being a dodecagon, let's say that it is a decagon. So let's say it has 10 sides instead of 12 sides. If I wanted to do the exterior first, I could do 360 divided by 10. Which is 36 degrees. So the exterior angles will all be 36 degrees. And if I'm looking at a figure here, and I tell you that the outside angle is 36 degrees, what would be the easiest way to find the inside angle right next to it? 180 minus 36. And that would give us 144. Okay, so do we even have to use the n minus 2 times 180? Not necessarily. Could we? Absolutely. Like on over here, we did the 12 minus 2 times 180. It would give us the same answer and it would give us the same result, but just a little bit different way of getting to the same answer without having to use that formula that we did yesterday. So once again, it all kind of depends on the question that we're being asked. What are we looking for? What are we trying to find? But you don't always have to find like the interior first and then the exterior first. Try to think about it in a little bit different way. And remember that they make a linear pair. They always make a line. The interior and the exterior will always make 180 degrees. So if they make a line, and I know one of them, I know the other one is 180 minus the first one. Okay, fairly short lesson today because it's day 2 of what we did yesterday. That'll give you some time to work today. I'll go get your assignment, make sure it's up. If you didn't get yesterday's done, let's get yesterday's done as well.